Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain how you can obtain the confidence interval for the population variance or the population standard deviation. So here we are going to assume that the population from which the sample is selected is approximately normally distributed, and therefore the confidence interval for the population variance is given by this one here. And I'm going to explain a little bit about this notation. So first of all is what's the meaning of n? N here is the sample size, and so the value of n minus 1, for instance, also represents degrees of freedom, and this value is required when you want to refer to the chi-square distribution for finding the p-value or the critical value. Yeah. So next is s squared. So s squared here represents the sample variance. Okay, sample variance. And at the bottom part here is something that looks a bit complex, but in reality it is not so much. And I'm going to explain these two symbols here using a simple visual representation. Yeah. Okay, so let's say we have the chi-square distribution curve, which looks like this. And here we have alpha over 2. So notice that alpha over 2, and on this side we have 1 minus alpha over 2. Okay, so alpha over 2 and 1 minus alpha over 2 is explained in this sentence here, where it refers to the area in the right tail of this distribution. So if you have an area which is equal to alpha over 2, you can imagine that this is going to be a small area because alpha itself is a small value. And if you divide by 2, it's going to be even smaller. Yeah. So if I imagine the area represented by alpha over 2 in the right tail of the chi-square distribution, well, it's going to be looking like this, more or less. So this is a small area, and this is equal to alpha over 2. And this symbol here represents a specific point on the horizontal axis. So this is the point on the horizontal axis. So this point is called chi-squared alpha over 2 because it gives the area from this point to the right. So from this point to the right, the area is going to be alpha over 2. Okay, the probability, or in other words, the probability of getting this point and larger than that is going to be equal to alpha over 2. So that's the meaning of this symbol here. Okay, it is the point on the horizontal axis. So this is the point which gives the probability to the right of this value here is alpha over 2. Alright, now let's go to the next symbol. Let's move on to the next symbol, which is this one. So if I sketch the chi-square distribution, it's going to be looking like this. And if you refer to this value, so this is the area here is going to be definitely much larger than this one, because here we have 1. 1 is the total area under the curve. You know that total area under the curve here is going to be equal to 1. So 1 minus a small value, you will get a very big area in the right tail of the chi-square distribution. So you can imagine the area is going to be maybe something like this. So the area here is 1 minus alpha over 2. Okay, so that is the area. And notice that, as I said earlier, the area under the curve is equal to 1. So if the blue area is 1 minus alpha over 2, you will see that this area also is going to be equal to, this is alpha over 2, because when you add them up, total area must be equal to 1, right? So that's just the additional point. And however, if we talk about this specific symbol here, so chi-squared 1 minus alpha over 2, what it means really is the point at this particular position on the horizontal axis. So this point is situated on the horizontal axis, and this point is going to be called chi-squared 1 minus alpha over 2 because it gives the area from this point to the right. So from this point to the right, the area is going to be 1 minus alpha over 2. So basically that's the notation used in this formula given above. Now, of course, if you want, you can actually combine these two figures into one big figure, which is going to look like this. So basically, this is the figure. And so if you have this area, so you have this area, this is alpha over 2. And so this point in particular on the horizontal axis is going to be called chi-squared alpha over 2, which is this one, okay? Now, next, if you have 1 minus alpha over 2, so which is from this one, and it goes on until the end, so until the end, then this particular point on the horizontal axis, this point on the horizontal axis is going to be called chi-squared 1 minus alpha over 2. So that's the meaning of these two symbols which you have seen on the formula above. And recall what I have said about the fact that total area is going to be equal to 1. So you know that from this yellow, you know that this yellow area here, from this point to this one, is 1 minus alpha over 2. So I'm just going to write down here. So this area until the end, according to this one, is 1 minus alpha over 2. And I know that total area is 1. Therefore, you can actually say that this area must be equal to alpha over 2. So this alpha over 2, the blue area here, is similar to the red area, the total area. So this is alpha over 2, and the red area is alpha over 2. Okay, this red area here. Okay, and so if you want to talk just this particular area, for example, this area to this one, this area is going to be equal to 1 minus alpha. Okay, so I hope you can see what's going on clearly based on this simple sketching and playing around with the area. Okay, so now notice that if you look at the presentation of this, we know that the chi-square value, which is on the horizontal axis, they are all positive value, and this I have already explained to you guys during our Google Meet session. So it is all positive value which started from point 0. So you can see that the point here will get larger and larger as we move along this direction. So if you talk about comparing this value and this value, you will see that this value will be a small value compared to this one here. So this one is going to be a big value. And let us look at the construction of the confidence interval. Yeah, when you construct a confidence interval, so this is the confidence interval. This one is the lower limit. Okay, so this one is the upper limit. As the name itself suggests to you, the lower limit means the value here must be definitely lower than the value given here. For example, if you talk about the value of variance between 20 to 30, this is okay because this is the lower limit. And this is the upper limit. Lower limit has to be a value that is lower than the upper limit, as the name clearly suggests to you, yeah? Now, I hope that you will see, based on the construction of confidence interval formula given above, you will see that here we have n minus 1 s squared, and here we also have n minus 1 s squared. So you can see that on the top part here we have a similar value, and at the bottom part we have this value, which is chi-squared alpha over 2, and this is chi-squared 1 minus alpha over 2. And you can see from this simple example here, simple construction of this formula, chi-squared over alpha over 2 is this value. So this is a big value supplied at the bottom here. So, and this is a small value supplied towards this part here. And by doing this, we will see that the value here is going to be small, and the value here is going to be big. So lower limit is smaller, and upper limit is a bigger value. Okay, I hope you can see that, because here we have on the top part here we have something that is similar on both sides, but this value is divided with a big value. Chi-squared alpha over 2 is a big value, so you have some sort of a value divided with a big value, you will get a small result, yeah? And here we have this value divided with a small value, and the result here is going to be a big value. So the upper limit here is a big value, the lower limit here is a small value. Now let's look at the simple example here. Suppose that alpha is 5%, degrees of freedom is 18. Find the values of this one and this one. So we're going to start off by sketching the position of chi-squared alpha over 2 and chi-squared 1 minus alpha over 2. Alright, so here is the, chi-squared distribution. So alpha over 2 is this one. This is alpha over 2. And next we have another area, which is 1 minus alpha over 2. So this could be 1 minus alpha over 2 towards the very end of the distribution. So this is 1 minus alpha over 2. So now alpha here is 5%. So therefore this area is equal to 0.025, and this area will be 0.975. 1 minus 0.025 is 0.975. Okay, so now our job is to find this one first, yeah? For alpha over 2, this one first, we need to find what is this value, chi-squared alpha over 2. Okay, degrees of freedom is 18, so we go straight to 18. Alpha here on the right tail of the distribution is 0.025, so you can refer to 0.025, and therefore this value is 31.526. So here is the value, which is 31.526. Okay, next is this one here. From this area, so this is the area here towards the very end, and the area is equal to 0.975. And based on that, we can refer to degrees of freedom 18. 0.975 is this one. Therefore, the value is 8 point. So this value is chi-squared 1 minus alpha over 2. And the value here is 8.231. So that is the two values represented by these symbols given here. So now, do you think you can obtain the confidence interval for the population standard deviation? Yes, definitely. So how can we obtain that? We can obtain that by squaring the results. Okay, so if you want to find the confidence interval for the population standard deviation, it is going to be the square root of the result, which is n minus 1. This is s squared over, this one is chi squared. So this one is alpha over 2, and this one is n minus 1 s squared, and this is chi-squared 1 minus alpha over 2. Alright, I think that's all for now. I will continue with a concrete example related to calculating the confidence interval for the variance in the next video. Thank you very much for watching.